So, my name is Sinjakli, and today I'm going to talk to all of you about how to restart databases without your applications noticing. For a little bit of background, I work as a site reliability engineer at a company called GoCardless, and we're a payments provider. We're primarily an API, so you do things like post to cash monies, amount 100, and we take money from your customer, get it over to your bank account, and everyone's happy. Because of the nature of our API, we have a relatively high value on each request. It's not like sending a social media post where if it fails, it's not the end of the world. If things start to fail on our end, our merchants start to lose money. So it really matters that our API is highly available. Merchants expect us to work pretty much like electricity or plumbing. It's just there in the background and doesn't go wrong. So for us, uptime is key. If we're down, then our merchants are losing money. And if we do that too often, we'll lose our merchants. All of the important data that we have, everything from customers to the money that's being transferred to the bank account details, is stored in Postgres. And there's a number of reasons that we like it and trust it as our main store. It offers good durability guarantees. When a message has been, when a write has been acknowledged by Postgres, you can be pretty confident that it's been written to disk, and if you've set up replication properly, it has been copied to another server. I'd also say that the core team of Postgres is relatively feature cautious, which chimes well with the way we like to do engineering. We would rather that Postgres gave us a new feature, well built and having gone through, many years of thought, rather than rushing something into the next release and it kind of not being quite right. Also, this is just a belief of mine, transactions are really cool. Like being able to do multi-object transactions, say, save all of this stuff or none of it, is very, very helpful to developers and helps them to get things right more often, which is great. But Postgres does have this one problem, and it's this. Postgres is like, speak to this one node. It has a single writable primary in its default replication mode. And you can have read replicas, but you can never write to more than one node. And that's what we're going to focus on today. Let's start by starting a company. We've chosen Postgres, and we've written a client, which is like some Ruby on Rails app or whatever. The data's all in one place. We have a single Postgres node. And we realize that's no good. So we set up replication so that we have our data in two places. What happens then, say we encounter some sort of failure, the node disappears, Amazon decide to just pull it out from under our feet or whatever, and this happens at 3 a.m. So we wake a human up. They arrive to the scene, and they see something like this. What they then need to do is promote the old replica to become the primary node, reconfigure the clients to talk to that, bootstrap a new node, and set up replication in the other direction. What's the problem with this? Your time to recovery is awful. You've had to page a human. They've had to open their laptop. They've had to figure out what the hell's going on, and then they've had to reconfigure some apps. It's also very error-prone, so you're going to be following some sort of run book in the best case, and you've got to follow every step in that right. So the problem there is you're following many steps. You've got to get them in the right order, and you've got to do it perfectly at 3 a.m. So real talk, don't make a tired SRE think. What you want to do is add automation. Automation is a solution to well-understood processes, especially where they involve high risk. How did we go about that at GoCardless? Well, we used a clustering tool called Pacemaker. It supports many different things, like MySQL as well, but we only use it for Postgres. Oops. Let's take another look at our setup. We want to turn this into an automated cluster of Postgres. And there is something missing. We need the ability to know that a node has failed. And to do that, let's think back to a series of blog posts that I'm sure a lot of us are familiar with, which is the Call Me Maybe or Jepsen posts by Kyle Kingsbury, where he talks about and pulls apart many data stores and goes through a lot of this concept called quorum, where you need 3 or more nodes to handle failure. The reason for that is that if you only have 2 nodes and you separate them, they can't know whether the other node has failed or whether it's just kind of not able to speak between them. If you've not read them, I highly recommend going away and reading those blog posts. They're some of my favorite things on the internet. It's basically torture for databases. So let's fix that and add a 3rd node. We'll install our clustering software on every node, and we'll have that clustering software manage a virtual IP address. Now, this virtual IP address sits on the same node as wherever the current writable primary of Postgres is. We have our clients connect to this rather than the IP addresses of the nodes. Let's go back to a failure. This time, the other two nodes are able to see that failure and agree as a majority that that node is gone. So they demote it. This can be done through many mechanisms, including shooting the other node in the head via some management backplane or second network that you have. There's all kind of weird stuff there. But they use some mechanism to demote the old one. You elect a new one. In this case, we've chosen the one on the far left, and set up replication going to one of the other replicas. We move the VIP across, and the clients follow. You provision a new node, and then that can rejoin the cluster as a replica. And everything's good. Seems kind of hard, right? Like, we've already introduced a whole bunch of moving parts there, and we've not spoken about anything to do with zero-downtime upgrades yet. And real talk, it's hard to run a database well. Like, to do everything we just showed in that diagram, you've got to know Postgres. You've got to know a bunch of stuff, like just in general about distributed systems and how they work. And you've got to know the specific clustering tool that we use called Pacemaker. So my advice to most of the room is get someone else to run it for you. Heroku and Amazon both offer pretty damn good Postgres hosting. And if you don't want to have something complex to manage yourself, go and pay them some money. So back to the point of the talk. What happens when we want to move on to zero-downtime upgrades? Let's look at the setup again. And let's not think about replication for now. We can use this virtual IP address to move clients to whichever node that we've promoted to primary. But there's an issue from those clients' point of view. Every time you move the VIP, all the connected clients get a connection reset down the wire from the Linux kernel. What that means is they all see a connection reset and drop the requests that are currently being handled. Every move means that we turn our API into this, which we don't want. So, what does it mean for upgrades? Well, let's look at a typical upgrade that you might want to do. Let's say you're running Postgres 9.4.9, and you want to get to 9.4.10. Let's bring replication back and upgrade those replicas. Now, this is an easy step. Postgres guarantee that between these rightmost version numbers, they will always keep the same replication format. You can upgrade those replicas, no problem. The issue comes when you want to upgrade that middle one. You have to move the VIP, and when the clients move to follow it, they all get connection resets. So, every upgrade means a connection reset, every upgrade means drop requests, and every upgrade means our merchants see this. So, the solution is obviously to never upgrade your software. Now, right, that's not a thing. This is a really strongly held belief of mine and most people, if not all, in the engineering team I'm in, is that you can never choose to just not upgrade a piece of software forever. And the reason for that is it's just terrible for security. Like, every piece of software in existence pretty much experiences some sort of vulnerability at some time, and you need to be able to apply those patches. So you can either choose to work out how you're going to do upgrades now, or leave it and do it in a panic when something like Heartbleed comes along and says, hey, we can own all your servers. So obviously this is a non-starter. But where do we go from here? Now there's one thing I've not mentioned in the setup we've looked at so far. So we'll go back to the setup and introduce something called PG Bouncer. PG Bouncer is a connection proxy that we run on every Postgres node in our cluster. PG Bouncer is what the clients connect to, and then it decides to forward on that connection to the actual Postgres instance. What that means then is we can introduce a second VIP so that PG Bouncer knows where to connect to. And luckily for us, PG Bouncer has this one weird trick. It's a layer 7 proxy, which means that it knows about the Postgres protocol. It's not just a dumb thing operating at TCP. It can actually handle different Postgres things. And the trick we care about is pause. What pause does is it holds all inbound queries destined to PG Bouncer and puts them into a queue. You can then resume and choose to send them on later. So how do we use that for upgrades? If I do this, then we can move the VIP that points to Postgres around as much as we like. And the clients have absolutely no idea that we're doing this because every query is held right at the top. What does this mean for upgrades? Well, let's make a bit of room on this diagram first. We know we're running some clustering software, so let's get rid of it. Let's go back to where we were in that upgrade earlier on. So we've got the last remaining node on version 949, and it's the current primary node. We pause our queries, we migrate to one of the other nodes, we resume queries, and finally, we upgrade the last node. Great. Now, I'd love to say that we're done here, but I'd be dishonest to tell you there are no caveats whatsoever. So I'll leave you with some food for thought. So far, we've only done this for minor versions, the rightmost number of that. So that's things like 949 to 9410. The reason for this is that between versions like 9.4 and 9.5, the replication protocol is different. If you've upgraded a node to 9.5, it can't connect back to the primary that's on 9.4. There is some hope here, however, in the form of PG Logical, which is a plugin that works with Postgres 9.4 onwards and guarantees replication format compatibility. We've not done this yet, but you can totally adapt what we have done to do major upgrades. Another thing is long-running transactions. If you run transactions against your database that take a certain amount of time, beyond, say, a few seconds, you may have to interrupt them to do this process. And the reason for that is that if a query has already made it through PG Bouncer, when you hit pause, that's going to keep running on the node. So you have to decide either I'm going to kill those off during the migration, or I'm going to abandon the migration if those are still running. We chose the latter for safety, which means that we have a busy loop that looks a little bit like this. While there are running queries on the primary, wait for some timeout and poll. If we reach the timeout, abandon. And if we manage to fall through all that, promote the new primary. It works for us, but you may want to go the other direction and force the migration to go through. The last thing is pause length. While you're in the middle of all this, your API is effectively on pause. What we've seen when we've measured this is that we see a roughly 7 to 10 second pause. Now, we think we can get this down. Most of that time is spent inside the pacemaker clustering stack, and we've been able to kind of more by hand with some scripts get Postgres to do this trick way faster. We've not gone beyond this because we don't need to go any faster. API clients are generally not that picky, and you don't have to upgrade Postgres all of that often. Cool. Now we're actually done. But there is one more thing. Everything I've talked about today is kind of nuanced. Replication is a nuanced concept. Clustering is a nuanced concept. And the script that does all of that migration stuff, I mean, it's just sat somewhere in our infrastructure. So to give you a better chance at having a go at this stuff, we've decided to open source our setup. So if you go now to github.com/GoCardless/our PostgreSQL setup, is hyphenated, you can have a play with everything I've just talked about. Before I stop for questions, I'd just like to say that we are hiring. And if this kind of stuff interests you, or just general building reliable systems stuff is your kind of game, then come have a chat. Thank you.